Good evening, children. So let us move on to the assertion and reason. Before that, I am welcoming you to 1 mark solution. So all the 1 mark, not only this subject, all the subject it is available. Please like, share, and subscribe also. So let us move on to the assertion and reason from the chapter electromagnetic waves. Unit is electromagnetic waves, very small chapter. We are dealing with electric and the magnetic field. Both electric and the magnetic field will be there in electromagnetic waves. Electromagnetic radiation, we can say. So now let us move on to this. So first assertion we can say. What is assertion? Sound waves cannot travel in vacuum, but light waves can. Sound waves cannot travel in vacuum. You just think about, but light waves can. Absolutely correct. Why? Because you have studied in 9th standard the sound waves, more about sound waves, and you know the bell jar experiment and all, isn't it? So assertion is absolutely correct. What about reason? Reason we can say light is an electromagnetic wave, but sound is a mechanical wave. See that? Light is an electromagnetic wave, but sound is a mechanical wave. That is also correct. From this assertion and reason, you can study that also. So here both assertion and reason are true, and reason is the correct explanation for the assertion also. Let us move on to the second one. What is the second one? We can say that the microwaves are better carriers. Microwaves are better carriers of signals than radio waves. That means for the transmission, we are using microwaves. Then, reason, the electromagnetic waves do not require any medium to propagate. That also we know that. So both assertion and reason are true, but here we are not pointing about the properties of the microwaves. Why we can use these signals for the transmission. There won't be much bending there, isn't it? It will go straight and we will get the correct transmission there. That is why we are using the microwaves. So the answer is B, option B. Now let us move on to the third one. Transverse waves are not produced in liquid and gases. It won't be produced in liquid and gases. And what about reason? Shorter the wavelength, the larger is the velocity of the propagation. No. V is equal to nu lambda. Again, we can say when lambda increases, velocity also increases. So here the reason is, we can say, what is the reason here? We can say it is not the correct explanation for the assertion. So here we can say transverse waves are not produced in liquids and gases. And the reason we can say shorter, it is not the reason correct. Shorter the wavelength, larger is the, it is not larger. It is also false. Okay, it is written not correct. Please note this point. It is not correct. Shorter the wavelength, it is will be less. So velocity also will be less. Okay, by mistake it is there. So please note it. It is not correct. The reason is false. So we can go for the option C. Okay. So now let us move on to the fourth one. What is the fourth one? The energy contained in a small volume through which an electromagnetic wave is passing oscillates with the frequency of the wave. Yes, absolutely correct. So energy density of the wave is given half epsilon 0 E squared. Energy density in the capacitor we can say half epsilon 0 E squared. But energy density of electromagnetic wave, we have to go for magnetic field, magnetic energy density. That is half mu 0 B squared. That is the answer. So here we can say the option will be D. That means the assertion and reason is false. Let us move on to the fifth one. Like light radiation, thermal radiation are also electromagnetic radiation. Electromagnetic radiation, we can say thermal means something related to heat. Infrared, that is also will come under in electromagnetic radiation. You know that visible light and after that ultraviolet and next one infrared. So it is also an electromagnetic radiation. Thermal radiation requires no medium for propagation. So here assertion and reason is true, but we can't say due to this only, what is that? It will come under electromagnetic radiation. No. So it is not correct explanation for this one. So the option is B. Now let us move on to the sixth one. X-rays cannot be deflected by electric and magnetic fields. It cannot be deflected. That means why? Because X-rays we can say the electromagnetic waves, isn't it? So we can go for next one. These are electromagnetic waves. Reason we know that X-rays are electromagnetic waves, isn't it? So that is the correct explanation for the assertion. Now, so what is the option we can say? The option will be A. You can see the option is A. Now let us move on to the seventh one. What is the seventh one we can say? EM waves. Again, electromagnetic waves are transverse in nature. What is transverse in nature? If this is the direction of propagation, you can see this is the direction of propagation. Now we can say that the magnetic waves will be moving perpendicular. That means vibration will be perpendicular. If it is like that, we can call it as transverse. There are two types of waves, transverse and longitudinal waves. So you can note that one. This is absolutely correct. Waves of wavelength 10 millimeter, radio waves and microwaves. No, it is absolutely wrong. So what is the answer? We can say assertion is true and reason is false. So you have to study all the range of wavelength and frequency also in the electromagnetic spectrum. Then only you can answer them. And your one question will be sure from electromagnetic spectrum. Now let us move on to the eighth one. Dipole oscillation produce electromagnetic waves. Dipole means what is it? Electric dipole, both positive and negative charges. If it is oscillate, it will produce electromagnetic waves. We know that when a charge is moving, they will produce magnetic field. If the charge is moving in this manner, we can say both electric as well as magnetic field will be there. Why? Because we know that the process of electromagnetic induction takes place because of the change in magnetic field. So dipole oscillation sure produce electromagnetic radiations. So what is the reason? Reason we can say accelerated charge produces electromagnetic waves. Accelerated means it is moving, isn't it? That means velocity is changing. If it is uniform, it won't be producing. So accelerated. It's a very good example. We can say it is given in your textbook inside the bracket. Accelerated or oscillated charge produces electromagnetic waves. Please note that point. So what is the answer here? Assertion as well as reason is true. And the reason is also the correct explanation for the assertion. Let us move on to the ninth one. In an electromagnetic wave, magnitude of magnetic field vector B is much smaller than the magnitude of the vector A. Always we will say that the magnitude of the magnetic field vector, that is magnetic field vector, two vectors will be there in the electromagnetic waves, E vector and B vector. So here we can say that B vector, here we can say the just a minute. Magnetic field vector will be less than that of the vector. Okay. So now let us move on to the reason. This is because in an electromagnetic wave, E by B, that is equal to C, 3 into 10 raised to 8. That means velocity of light. Velocity of light in vacuum is 3 into 10 raised to 8. Because of this only, we can say the assertion is correct. That means the reason is the correct explanation for the assertion. We can say E by B is equal to C means B will be less anyway, sure. So we can, what is E? B into C. So anyway, E will be greater. So assertion as well as reason are true and the reason is the correct explanation for assertion. So the option is A. Now let us move on to the next one. 10th one. The gyrating electron can be a source of electromagnetic. What do you mean by this gyrating? Gyromagnetic ratio is there in the magnetic field that you are studying. An electron is revolving around the electron is revolving around the nucleus. That we can call it as gyrating. It is moving anyway. Can be a source of electromagnetic wave. Sure, electron is a charged particle. So when it is moving, it will produce an electromagnetic wave. Now what is the next one? The electron in circular motion is accelerated motion. Electron in a circular motion, we can say it is an accelerated motion. So as assertion, no doubt it is true. And what about the reason is also true. And it is the correct explanation for the assertion. So the option is A. Thank you. Thank you for watching.